Okay, let's take a look at problem 4, using rational expressions to solve a problem. In construction, your community is building a park. It wants the fence and a play space for toddlers. It wants the maximum area for a given amount of fencing. Which shape of a square or a circle provides a more efficient use of fencing? One measure of efficiency is the ratio area fence to fencing used, or area to perimeter. Use the two shapes as which of the two shapes has the greater ratio? So here we have the information for square. Area is equal to side squared. Perimeter is equal to 4s. For area of a circle, we know is pi r squared. Perimeter is equal to 2 pi r. All right, so here, if I want to find out area in terms of perimeter in terms of area, I need to solve for my perimeter. So I'm going to divide both sides by 4, and so my side is equal to perimeter over 4. And so now I can plug this in for S for area. So P over 4 squared. So everything will be in terms of just one variable P. And so when I simplify, I get P over 16. We do the same concept here. Instead, for looking at perimeter, we're going to solve for R. And then I can take my P over 2 pi and plug it into the area. And I get pi over P over 2 pi squared, because that's what R is equal. And when I simplify, I get P over 4 pi. Alright, so it says since P over 4 pi is greater than P over 16, a circle provides a more efficient use of fencing. So we can check it out by assuming that P is equal to 40. So if I put P in for 40 in for P, I get the area of the circle is 127 and the area of the square is 100. So the area of the circle is greater. Alright, so let's look at the guide. It says, which shape of play space provides for a more efficient use of fencing, a square or equilateral or triangle? I don't know why we didn't do the circle. We already know the circle is better, but we're going to try the square or the triangle instead. Alright, and so they give us a hint that the area of an equilateral triangle is 1/2 s times the square root of 3 over 2s, and the perimeter of the equilateral triangle is 3s. So I've written it here on my whiteboard. And again, I am going to solve for P in actually, first thing I'm going to do is I'm going to go ahead and simplify this more. And I'm going to get the square root of 3 over 4s squared. I just think that's a little bit easier to see. Alright, and then for perimeter, I can solve for S, and I get S is equal to P over 3. Okay, and so now, this is my area. I can find out what area is in terms of perimeter. So I'll say area is equal to the square root of 3 over 4, and instead of putting in an S, I'll put in P over 3 squared, and I'll evaluate that, and I get P squared square root 3 over, this is 9 times over 36. Alright, so there is my area, and so now I can place that over my perimeter, and so this is the ratio that they provided for us. And so I have P squared square root of 3 over 36 over P, and so I can change that to P squared square root of 3 over 36 times 1 over P. And so one of my P's crosses out, and I'm left with just P square root of 3 over 36. Okay, so I've run out of space, so I'm going to have to erase some of this. I apologize. You can rewind it, go back and look at it, pause the video, whatever you need to do. Okay, and so we want to compare P square root of 3 over 36 to P over 16. I want to see which one is actually greater, and so I'm going to have to use my calculator. So I have square root of 3 divided by 36, which gives, did I do it too many times? 0.08. 0.05. We'll round to 0.05. And 1 over 16 is 0.06. So this time the square is greater. And we can test it out like they did. We can plug in any number. Let's plug in 40. So 40 times the square root. Whoops. So square root of 3 times 40 divided by 36 is 1.9. So P is equal to 40 feet. And then 40 divided by 16 is 2.5. So that's why the square is a better shape. Let's see if I missed any part of the question. Nope, I hope this helps.